we have the bounding boxes for the different players. In the top left, we kind of have this 2D coordinate showing like where the players are on the 2D court. You can see we have the ball being tracked. And then I think the most interesting part from all this clip is kind of like what you're seeing at the top, these actual events that are being detected and tracked by the AI. And so what we've done at PlayVision is we've built out a front end and back end where coaches can easily, break down these games and analyze and see what's going on.
On the screen, we see a basketball game underway, and we also see the visualizations related to some AI models that are running on that basketball game footage. And at the top of the screen, you might notice that there is these analyses of the actions that are taking place in that game. Well, today, our guest speaker helped create this demo. He is coming from a company called PlayVision, and they're helping sports teams generate more detailed reports using computer vision and their solutions that they've created. And so today we have our guest, Marc Zoghby, who is from PlayVision, and he's going to help talk about how computer vision is helping teams, better understand that game footage that we just looked at. So, Marc, would you like to introduce yourself?
Thanks again for having me, Patrick. Really excited to share a bit more about PlayVision and how we kind of build out these computer vision solutions. And so, yeah, I guess a bit about PlayVision is, we are a sports tech company. What we do is we leverage AI and computer vision to automatically analyze game footage, breaking down games automatically, and providing teams and coaches with advanced stats that go way beyond like a typical box score. Um, I guess kind of like where this whole idea started kind of just ties into how I met my co-founder. My co-founder, he scouted actually for Berkeley's athletic department. We both went to Berkeley, and we met in this AI and sports tech class, funny enough. And he was in the film room, always manually tagging different stats and different actions that were going on. And I had this background in AI and CV. We could talk more about that down the line. And we're like, why don't we start a company around this, since this was a pretty pertinent problem across the board for coaching staffs. So that's a little bit of context. I would love to just hop in a quick demo and kind of show you guys some of the tech that we've built.
Please, yeah, I think the best way to get to know a solution is to see it in action. So please feel free to take over and
Awesome.
you could show us what you guys are working on.
All right. So the first thing I have here is similar to is basically the same clip that Patrick was showing you guys on the starting slide, but I'll just let it kind of run through and explain what's going on. And you can see that there's a lot that's happening. I'm going to pause for a second. We have like these pose model, right? We have the bounding boxes for the different players. In the top left, we kind of have this 2D coordinate showing like where the players are on the 2D court. You can see we have the ball being tracked, who has the ball, and things like the hoop. And then I think the most interesting part from all this clip is kind of like what you're seeing at the top, these actual events that are being detected and tracked by the AI. And I'm sure like a lot of people have seen like these AI and CV computer vision demos in the past. And the truth is that a lot of this the value doesn't actually come from the bounding boxes themselves, right? If you're a coach, you don't really care necessarily, hey, like, oh, these bounding boxes are really cool. You're actually more interested in the actual metrics and stats derived. And so what we've done at PlayVision is we've built out a front end and back end where coaches can easily, break down these games and analyze and see what's going on. So this is kind of like our film portal, right? And you can see we have our basketball scouting report. We can add games to that and create new reports. So if I'm a coach, how I would use this is I would go on over to new report. I'd go in here and upload a game like that. I can continue upload. I kind of fill out the details, like, what the report is, the game name, the league, game type, etc. Press continue, and that gets shipped automatically to our backend where our CV models, like the ones you saw in the video prior, automatically process and generate the stats automatically. And so what does that look like, right? Obviously, coaches rely a lot on the film, but they're not necessarily working with the annotations. But what's more interesting for them is like the actual stat tables that we can generate. So here's like an example stat table where we have those same metrics that we were seeing pop up on the CV, like the ball reversals, the paint touches, the passing accuracies. the type of shots that were occurring. Like, are they contested? Are they uncontested? And then we're generating the same stats for the players as well for both teams. And so if I'm a coach, I go in here and I can see, oh, looks like Tyler Lewis has a passing accuracy at 50%. That's solid, but I'd like to see that be a little bit higher so we can start generating more on our offense. And so that's pretty much the demo wrapped up, and would love to hop into any questions that people might have, and we can just take the discussion from there.
Totally. Yeah. Thank you so much for showing off that quick demo. I want to jump right into actually one question. I prepared a quick slide here where in the demo that you showed, I see there's this one kind of like dribble handoff, and then there's a note at the top that says good pass. And then later in the clip, there is this part. It's like, I don't know, to me, it looks like maybe like the slowest bounce pass that I've ever seen into the paint. And then there's a pop-up that says bad pass. What's going on here?
Yeah, this is a great question, and it's actually why it's very valuable to build with the end user and the customers. And so, I mean, to start off, like, we didn't necessarily know what a coach considers a good or bad pass, and then we started talking to them, and it seemed like the consensus across the board had to do with, where was the pass ending up, right? So, like, if you're a player, right, and you get a typical pass, and you have to like kind of jump to catch the ball, or it's like super low, and it's kind of like difficult for you to actually just gain possession, and just adds a lot more difficulty. That tends to be classified as a bad pass for these for these coaches. And so we kind of design like a system where, like, okay, when we first detect when the passes occur, and then the second part is like, okay, what's like kind of the contextual awareness of the pass? So is it like how fast is the pass going? Where does the pass end up when the other player catches the ball? Are they grabbing it above their head? Are they bending down before their waist? Are they jumping, etc.? And that's how that kind of system is built, and how we tag that at scale. And I mean, what we learned just from talking to coaches is that it's very tedious to actually track all these passes. Like in a single basketball game, for instance, right? And even in a possession, you can have so many fast moving passes, and it's tough to just track all these things one by one versus having a machine do that automatically for you.
So my first kind of jokish follow-up question is, should basketball teams only do dribble handoffs? Is that the takeaway from this?
No, I mean, in this example, yeah, we see the dribble handoff being a good pass. Obviously, there's like more tricky scenarios. Like obviously there's lobs, and the criteria for lobs is actually different there's no lobs in this example, but a lob tends to be above a player's head. But like same deal, like talking to coaches is like, one, okay, identifying the lob, right? What separates a lob pass from, a bounce pass, for instance? And then the other part is like, it's actually different criteria. If you're a coach and you're giving a lob pass to, say, a guard is giving a lob pass to their center who's, just outside the restricted area, there's actually a region kind of like right in front of the basket that you want that pass to be received. So obviously it changes on the context, on the type of pass that occurs. And we by no means haven't yet created the full end-to-end solution to address all those passes, but that's what we're working towards as we continue to iterate and refine our models to add more and more capabilities.
I really liked that you said, basically the vision model is not the end goal, right? Like the vision model is a tool to help us get to the end goal of, having a finished game, 48 plus minutes, putting that into a system, and then having detailed analytics for the players and the coaches and other staff. Do you have any sort of favorite examples of statistics or insights that you've been able to glean from this system that, perhaps it might not have been feasible for a human to glean that?
Yeah, I think, there's actually two kind of case study stories that I want to talk about. The first is actually when the eye test kind of matches what the analytics show. And so like if you're a coach, like eye test is like something that they will swear by a lot of the time. And so and a lot of times they'll be like very like um it'd be hard for them to accept a stat if it doesn't necessarily agree with their opinion in some scenarios. And so when you could kind of confirm that with the data, like that actually gets them really excited. So an example of that is like we kind of broke down the points per possession based on the number of passes across these possessions for different teams. So like we'd have like, oh, let's for example, it was 2 points per possession when there were only 2 passes versus when we had like 10 passes, the points per possession was lower, like 1.2. And they kind of dig deeper into this, like why would there this difference across like only like short like possessions with shorter passes having a higher points per possession, which is actually an interesting question. And what we realize is that the possessions where there are way fewer passes tends to be something on a fast break. So there's maybe only 1 or 2 quick passes. The player is open, and so they get an easy layup or like a dunk, which tends to be like a way easier shot to make than, even this play we have in the example, right? It's like they're swinging the ball around, there's a paint touch, there's like these backdoor cuts, etc. There's more passes going on, and like it can create an advantage, but depending on the shot that and the contextual awareness, you're like, oh hey, that actually makes sense why possessions with fewer passes have a higher possession, just like from that standpoint. That's like an insight that I guess you could kind of infer based on like shooting percentages, but having the additional context of like, hey, the number of passes, that makes it like a lot more interesting. The second part of this was kind of a really interesting use case for like the passing accuracy stat itself. The one team was using our passing accuracy to actually compare guards. So they were looking at like the passing accuracies across these two and making an evaluation to help them assist with like these roster additions as they build out their teams. So that's kind of a little insight there and some interesting use cases and how data just one shapes decisions, how two data can help like support decisions, and also how it can like negate decisions that you might make.
Let's kind of talk a little bit about like your computer vision journey.
Yeah.
Could first, you mentioned this a little bit earlier, but could you kind of just talk about like your background, right?
Yeah. I mean, my background is I mean, I started coding during the pandemic. I had a lot of free time, and so school was online. So I spent a lot of time just kind of learning how to code, learning Python. And this was like 2020, 2021. And like, I just kept hearing all about AI. I didn't know too much about it and was really curious. And so I was fortunate enough to start getting involved with AI research actually pretty early at the Mayo Clinic. Worked on a bunch of projects from like, on the from like generative AI for like different MRI models to building like, like simple like classifications of different like, of tumors from like CT scans. So I that's how I know how I develop my experience initially. Like, so I just worked on a bunch of projects, learned, and I really started from nothing there. Like, I learned how to curate a data set, how to, pre-process, how to post-process, how to train models, how to track all these experiments. And so that's kind of how things started out. Just learning as I go. But keep in mind, like I started out like this is like purely academic setting. Like I had never deployed anything to production, built anything that people actually started using. And that's a transition. Like you can build flashy demos and you can build research projects, but to get something in someone's actual hands using and when something you build faces reality, you just have to deal with way more challenges and edge cases that you just didn't necessarily think of from the start. And so I'm by no means an expert, I would say, but I'm just hungry to learn what's been used in industry, what are people using nowadays, what's popular, what's not working, and that helps inform my own decisions as we develop our own models and infra.
I want to give people maybe a little bit better sense of sort of like what exactly you guys are doing before we talk sort of about models.
Yeah.
So I'm going to give you like a sort of like a two-part question.
Okay.
As I saw in the chat, we had a couple questions about like Can you understand which team is which? There was another question about some stuff about poses. There was another really interesting one I saw. Oh, some people were talking about like injury detection. That might not be the model itself. And then the second part of my question is like, are you guys only using custom models that you've trained yourself in like Roboflow, or are you like mixing and matching pre-trained foundation models that already exist, along with some custom models that you've made?
Awesome. Yeah. Yeah. Great. But let's kind of unpack a few things. I think for the first question, kind of um, what was going on at the computer vision. Yeah, there's a lot, and so my apologies if I didn't explain everything correctly. But there's just no problem at all. There's just so many pieces that go into it. One, right, is like the metadata layer of just like identifying the players themselves, the ball, the hoop to start off. But then there's a second part to that, which is like tracking. And so when there's a lot of occlusion, you have to have like a smart system that's able to continue to track these players um, across frames so you can associate and keep the identity. On top of that, there's also the team aspect, right? Being able to split and identify who is on what team. And so these are all challenges that we've solved. Like we've iterated and tested all these things. We've seen a lot of the models that come out in research, and those are great, but a lot of the times they have their own issues, whether it's latency and accuracy for these specific use cases, for instance. And so that's kind of like the initial layer of like first getting a sense of what are the movement patterns, what are the players doing, et cetera, on the court. And from there is how we start building and abstracting our data levels and start even building more complex models where you can start doing like these more advanced event detection. Um, I think that's the first question. The second question was like what type of models are we using? And it's a combination of our own custom models that we've built, some that we fine tuned, some that we've built ourselves internally. We have our own data sets, and I mean we work closely with teams, so it's easy for us to quickly expand our data, certain edge cases or different film angles, and then obviously like a lot of these like um, open source models like Roboflow obviously has a bunch, right? From the our RF Deader models, there's the YOLO models, there's the open source pose models, right? Those are very valuable because you can just easily fine tune them to your specific use case, and it saves you a lot of heavy lifting as a developer. Like you shouldn't have to hand code a transformer or a CNN from scratch to do object detection. Like people have already built out the infrastructure for you to easily train and fine tune your model for your specific use case, whether it's basketball sports film or it's I don't know, like I think the classic example is like cars in like a parking lot, or I don't know, different vegetation in the real world, or like medical imaging. Like I think that's like what's really great about this open source community, because you can build on top of that and then add your own twist as you develop for your specific use cases.
Could you kind of give me a quick overview of kind of like based on that? I really like what you said about there's like certain things you kind of like don't need to do yourself. Like I'm
Yeah.
kind of thinking human body key point detection. Like I'm kind of assuming maybe that's something that existed already and it wasn't like super hard to achieve yourselves. I'm kind of thinking about some other stuff though, maybe about like recognizing the numbers on a jersey, stuff like that. Would you be
Yeah.
able to share anything about like what kinds of challenges were like you could use some off the shelf things, off the shelf models, and some other
Yeah.
situations where you needed to train something custom?
Pretty much every model we use, we've had to do some type of fine tuning. Like you can try these things in like in production. Like I think a great example is like OCR, right? There are hundreds of models for OCR, and like when you one, like it's kind of like it can be overwhelming to even just pick a model. Like what's like the ideal model for my use case? Should I go with like a larger VLM? Should I go for like a smaller like transformer based or CNN based architecture? Should I like fine tune like a ResNet, for instance? Like those are all like important factors to consider. And I think you should use AI to help research the tool, like the type of models and tools that you use. Like you don't have to like don't do a Google search. Like literally use like ChatGPT or Claude or Perplexity, And it helps you do a lot of that exploratory analysis and research to find, one, what types of models are already out there for this specific use case, for instance, OCR. Two, like give you a sense of like what type of requirements do I need? Do I need to do much fine tuning or training? And for that specific model, for instance, you can try like an OCR off the bat, but we realized that we needed to quickly put together a data set, right? Because a typical OCR model is going to have no issue identifying numbers. Like if it's like on a very clear, but then like in a sports film, right? Like it's players are very dynamic, and so the angle of the numbers will change. It becomes very distorted. Like a 7 can sometimes look like a 1, right? So like you have to spend time training the model on like what's the actual scenario it's going to be, right? And so uh, in most scenarios, you have to do fine tuning for these more like niche use cases, especially if you want to put something into production, because at the end of the day, like you need to use what's going to actually be what your model's actually going to see.
Yeah, I think it segues nicely into some questions that I see from the audience. Really early on, I saw somebody just have like a really quick question of like, what's your approach to data curation? And then there were like a couple questions about like the source of your training data. Like, is this like the camera that's looking from the same angle as like the TV broadcast camera, things like that. And I think this is kind of one topic that I was hoping to get into today as well, about just like sort of like getting started. I think a lot of times my advice to people is like, don't be scared. Don't feel like you have to like have a billion images to start making your own computer vision model. Get started kind of small, get into testing, get something that could assist you to at least start collecting more images, create, in Roboflow, we have all these tools for like what we call active learning, where
Yeah,
you collect more images, you have it labeled by your initial model, and then like human in the loop to kind of review
yeah,
and then improve the model over time to expand the data set, things like that. So yeah, could you talk a little bit more about like data set curation
yeah.
and also like, when things start going wrong, and then like kind of like opportunities to improve your models and accuracy in the future.
Yeah. I mean, yeah, I think you have to view your data set as something living. Like it's part of your tech stack. It's like your code. Your code will change, your software will change, so will your data set, because your starting data set is not going to be your ending data set. And so like I think to start off, like for like especially sports, like there's a lot of like you can look on Roboflow. There are a ton of like open source data sets. Like you can find a ton of like basketball images, you can find tennis images, soccer images, etc. And so I think that's a very good starting point to train. And I wouldn't be discouraged by the fact that like, oh, this data set only has 500 images or 800 images or even 100 images. That's a great starting point to if you want to train like a more fine-tuned model. Also now with like SAM3 is great if you want to do jumpstart your data set. And I know Roboflow has like a quick model training. I think that uses SAM3 to quickly annotate your data set and um and then train like a smaller like RFDetter or a YOLO model on top of that annotated data set. And so yeah, that like when he started out, there was no like SAM3 to do that. So like that's a great tool to have now to like quickly expand out your data sets. And so to start off, right, yeah, like we worked to broadcast film, but a lot of the times these teams that we work with don't just have broadcast film. There's like different practice facilities, there's different game setups, there can be cameras that are way higher than the typical broadcast, way lower. And so what we learned and we started doing, right, is like we would just run our initial models on those clips, and then we'd filter out and find like low confidence detections or instances where we suspected that a ball was missing or a hoop was missing, or there were way fewer or way more players than what we would expect. And that in turn was, uploaded to Roboflow. And then, we had our human in the loop process where we'd go in and, make the corrections and adjustments as needed. And so I think the main takeaway is like treat your data set like a living object that's going to continue to iterate and improve. And also, I think this is very important that you might like miss is as you um, iterate on your data set, you need to have a measurable way to actually assess the impact and like how much things improve. So like, let's say you like, for instance, let's take the example of like different stadiums. You need a way to benchmark and see like, okay, before I fine tuned this model even further and did more of this active learning, what were some of like our basic accuracies on that versus later down the line. So I think that's also important because then it lets you like one, like measure progress incrementally, but also like as you train more data, you don't want to like lose accuracy in other stadiums, for instance. Like that's kind of you're taking a step backward and a step forward, which ideally you want to do one or the other. In my experience,
Capturing basketball footage in a way that is going to be like easy for a computer to understand can be a little bit difficult. I'm thinking about things like the amount of light in the gym, like the
yeah,
shutter speed of the camera. When people are moving quickly, you will very easily run into issues where you have a lot of like motion blur. And then the human brain can watch a basketball game, and if there's a lot of motion blur, we can fix that, right? Like we understand that a blurry image is a hand moving. Um, the AI model, kind of depending on what you do, might not recognize that, right? Kind of depending on its training data. Could you do you have any kind of like stories or kind of like advice for people related to the imagery that you put into training and then like applying it to imagery and kind of like making sure that you have results that are kind of like relevant, but also kind of like making sure that what you're putting in is high quality. Does that make sense?
yeah. I think there's two sides to this. There's the pre-processing and the post-processing. On the pre-processing, there's like I think there's two parts. One is like the quality of the data set itself. Like you don't want like a lot of mistakes in the data. If you're doing active learning, right? Let's say with like um a specific model, like there should only be like realistically 10 players on the field, right? And if all of a sudden you're seeing like 20 because your model is like identifying a bunch of people on the stands, that's been something we've had to deal with in the past, right? It's in certain venues and stadiums. And so that's one side of it. Like that active learning can help like mitigate those issues down the line. The second step part is also a lot of pre-processing that you can do. One of the reasons I love Roboflow is because it's very easy for me to like do all sorts of different pre-processing on my data set. I can add blurred, I can add noise, I can change the saturation or the hue of the image quite easily. And that helps address those other issues that you might run into where there's like different um, lighting conditions, um, like even like throwing like black and white images, for instance, just to like change it up to the model learns like the general context and doesn't try and like pattern recognize off of like a circular element being the ball. For instance, like early on, we would run into this issue where think like the players' heads were balls, which is like obviously not true, but like that's like something that could really happen if you're not careful with how you prepare the data. I think on the pros processing side, there's a lot that can be done with like, how you filter the detections, filtering at a lot of this is like textbook, like computer vision post processing, like filtering like low confidence detections, um, applying like NMS or like IOU thresholds when you have like a really significant overlap. That's another thing that can happen. Like a model will like have two bounding boxes around the same player. Like that's not something you can necessarily control, but like with the right post processing, a lot of that stuff can be eliminated. So hopefully there's like a few useful pieces of insight there, but yeah, I think those are some of my initial thoughts from your question.
Just for other people kind of working on computer vision challenges, do you have any advice for them to keep in mind?
I think the biggest thing is just like build something and test it right away. Like your product's first encounter with reality is probably not going to go well. And that's how you learn the most. Like my biggest learnings wasn't like sticking to the textbook research stuff, of like how I prepare my data set. And like, you shouldn't have to, like, for instance, you shouldn't mix data for your training and validation and tests, which is true. But like, when you're also evaluating like direct outcomes, like for instance, for us, it's very important that we have high accuracy across, you know, every stadium in the world, right? Like, we have to train on those stadiums and also test on the same stadiums, because like at the end of the day, like, we need to have like measurable impact in what we deploy. And so I think like that's like, at the end of the day, you want to build something that works and that is tangible. And so like the quickest way to do that is just breaking things and being clever in how you use your solutions, and leverage like the like frontier coding models and like the AI LLM, because they can, it's like a brainstorming buddy that you should be talking to and learning from, um as you kind of go on this journey, because there's so much knowledge out there just about AI and computer vision in this whole space. And so it should be the skill of being able to decipher what is relevant to your own needs, what your own goal in your project, is also like incredibly useful, in addition to just like general CV acumen.
Just a heads up to anybody who is maybe watching a recording of this later. If you want to join one of these sessions live in the future, head on over to roboflow.com/webinar. If somebody was interested in kind of learning more about what you guys do, if they're specifically interested, I don't know if we have any sports teams coaches on the call today, but yeah, if they want to chat with you further or kind of learn more from you, kind of like what's the best way to get in touch or kind of like learn more about PlayVision in general?
Yeah, I think the best way is, you can email me. It's just Mark at with playvision.ai with any questions that you might have, or etc. Or the other way, just through LinkedIn. Yeah, we try and be active. If you love like this basketball content in general, we're decently active on all platforms. So we have an Instagram account, Twitter account, TikTok, um, all those can be found actually through our website.
Have you experimented with Meta Sam 3D body models at all? So could you talk about that? Has that been something interesting to you? Have you experimented with it in the past?
If I'm being transparent, I have not. Maybe I should, but I've seen a lot more of these 3D models being open sourced, and I feel, yeah, like that. I think that the logical next step is going from this whole 2D and 2D boxes and 2D data to 3D data. I think, yeah, I think that's a no-brainer. Like, I suspect the models will be good enough, so long as you have like the right data for your circumstance. But I think there's definitely a lot more potential. I initially see things that related to injury prevention, honestly, with like more the 3D biomechanics, but definitely something worth. I think I'm definitely going to check that out more, and see how that could be useful here. And I'm sure there's a lot of other applications as well.
Okay. And also I haven't played around with it too much myself, but just for the audience's reference, we do have some SAM 3D capability built into Roboflow as well. You're interested in that, you could play around with it. Kind of last question from the audience that I'm going to try to toss at you is, for people who are interested in doing pose detection, I think this is, broadly applicable to not only like sports, but other like exercise apps, stuff like that. Do you have like any kinds of like words of wisdom or any advice for people based on your experience?
Yeah, I think it just depends on your use case for how you want to use pose detection. So if it's like a more custom approach, right? Like you're identifying, I don't know, this is like a contrived example maybe, but like different like edges on like on a plant, for instance. Like you're probably going to need a more custom data set and model built that. If you're working with objects that tend to um be pretty uniform, similar to a human, I think out of the gate, most open source models should do a pretty good job. You'll probably have to do some additional fine tuning and active learning, which can be painful, but it's probably something very important that's part of that process. And I think those are my main thing. I think I've seen some models out there that actually can, like, you can actually select what type of key points you want. And then it starts off with that, and then as you iterate, you can like expand it. It kind of like an active learning approach, kind of like what SAMP3 does for Roboflow, but like more so for key points. Yeah, there's definitely a lot of models out there that can suit your needs. I think it just depends on the use case. Same with like every requirement. You need to think at the end of the day, what's like the final outcome of this product? What's like my end goal? What type of model would and what model would like satisfy those needs?
All right. Well, let's wrap things up. Mark, thank you so much for coming, spending the better part of an hour with us this morning, talking about the cool things that you guys are building for sports teams. And then, just, I don't know, congratulations on like, just everything you have achieved so far. It's really awesome to see, you know, a full game footage being translated into this like rich report with all of these analytics. So very excited for that. And then, yeah, thank you to our audience today for bringing way too many questions for us to handle throughout just this short session. Go find some visual problems to solve with computer vision. And yeah, please take it easy, everybody. Thank you very much.
Awesome. Thank you.